Okay, let's try this 2018 A-level question. Right, the concentration of oxygen in a gas of 1 dm cube of water saturated with oxygen was found to measure at different temperature, and the results are shown. All right, so they give you all the different temperature, and these are the concentration of oxygen when it's at saturation. So the temperature of another 1 dm cube sample of distilled water saturated with oxygen is raised from 25 to 35 degrees Celsius and allowed to reach equilibrium. Calculate the amount of oxygen in moles which have escaped from the sample. So you can see from here, at 25 degrees Celsius, right, there's 8.24 milligrams of oxygen in 1 dm cube, okay, of solution. And at 35 degrees Celsius, the amount of the mass of oxygen in the water is 6.93 milligram of oxygen in 1 dm cube. All right, so you can see that when you increase temperature from 25 to 35, there was less oxygen in the solution because some of them has escaped. All right, so you can calculate the mass of oxygen that has escaped by finding the difference between these two values. All right, so you minus off, you get 1.31 milligram. If you want, you can convert to grams. Since the question is asking in moles, right? So that's why we are converting to grams. Okay, so milligram to grams is times 1000. Divide by 1000, sorry. Okay, divide by 1000. Okay, so the amount of oxygen, right, escape will be equals to the mass divided by the mR of oxygen, it's actually which is 32. All right, so this is the moles of oxygen that has escaped. Right, so let's look at the next part. Okay, so now they say once this is another vessel, 1 dm cube vessel, but this one contains pure oxygen gas. This is a gas, not aqueous solution. The temperature is 25 and the pressure is 100 kilopascal. So when the vessel is warmed to 35 degrees Celsius, the new pressure oxygen is 103.4 kilopascal. Okay, so now they say a sealed 2 dm cube vessel contains 1 dm cube oxygen gas, which is like this, 1 dm cube oxygen gas, and 1 dm cube of distilled water saturated with oxygen, which is like this. All right, okay, at 25 degrees Celsius, so the pressure is 100 kPa, all right, kilopascal, as you can see from here. This is only for the gas. Okay, so when the vessel Y, so this vessel Y, the temperature was increased to 35 degrees Celsius, and a new equilibrium is established. Okay, so what happened when it increased to 35 degrees Celsius? At 35 degrees Celsius, the pressure of the oxygen gas is 103.4. So it has increased from 100 to 103.4. So at 35, I'm going to write the pressure of oxygen here is 103.4. Okay, but you also must realize that some of the oxygen from the aqueous solution must have escaped. All right, and how much escaped? We got it from the previous part. All right, from part 1. Okay, so when you increase from 25 to 35, some oxygen gas escape. So this you can copy from part 1. So this is the number moles. So what's the pressure of oxygen escaped? Right, that's the next part. So we're going to use PV equals to nRT. All right, because you need to calculate the pressure of oxygen inside here, right? So it includes the pressure inside this part is the oxygen over here, as well as some of the oxygen that has escaped. So I'm trying to find out the pressure of oxygen escape using PV nRT. All right, so if you work it out, P is equals to nRT over V. Okay, so I'm going to show you the values. So N, R, T, T changed to Kelvin. Okay, the volume is actually just 1 dm cube. Okay, the volume where the oxygen is, right, 1 dm cube. So I changed to meter cube, so times 10 to the power minus 3. Okay, dm cube changed to meter cube. So this is the pressure of oxygen that has escaped. So the total pressure of oxygen, actually at 35 degrees Celsius, you have to add them up because you have the pressure of oxygen that has escaped here, as well as 103.4. So please add them up. Okay, this is the pressure of oxygen that has escaped from the water, the aqueous solution, and the existing one initially. So you get 103.5. All right. So the next part suggests why the actual value for the pressure recorded in vessel Y was slightly different. So why is it slightly different? Because imagine you have oxygen gas up here and it's saturated. Okay, there's oxygen gas up here. So because of the oxygen gas above the aqueous layer, so and yeah, this is pure oxygen. So it will actually prevent the oxygen from the aqueous solution from escaping. All right, okay, it will actually prevent, if it's up there, it's saturated with pure oxygen, it will prevent the oxygen from the aqueous layer from escaping. Previously in this example, we don't have pure oxygen above the saturated solution. Okay, saturated oxygen, we don't have pure oxygen above. But in this case, yeah, for this question, there's already pure oxygen above. So actually, this is what happens. The oxygen present initially in vessel Y suppresses the escape of oxygen from the distilled water. All right, from the distilled water. So yeah, maybe this time I should put on aqueous to O2 gas, aqueous. So hence, all right, hence less oxygen would have escaped. All right, less oxygen escaped, and this resulted in the actual value for the pressure to be different from the calculated value.
Thank you for watching the Twig Learning Center chemistry tutorial. I hope you learned something new. Don't forget to click the subscribe button so you'll be updated when new videos are posted.